So the next algorithm that we have is the priority scheduling algorithm. In this, our processes will be having some priority, and according to this priority, we will have to execute those processes. The very first thing, process with the highest priority will be executed first. So the process with the highest priority is supposed to be executed first. And if two processes or three processes have the same priority, then we will execute them in first come first serve manner. So if there is the processes, two or more processes have the same priority, then we will execute them in first come first serve manner. Okay, priority 1 is considered to be the highest priority. Means wherever you see priority 1, it's going to be the highest priority. If priority is 2, it is the second highest priority. If priority is 3, it is the third highest priority. So basically it works in a form of priorities are equal to your rank. We see the rank in schools. First rank is the best student or the highest marks basically. Second rank is the second highest marks, and third rank is the third highest marks. So it works according to the rank system. So remember this priority, the lowest is basically the highest when it comes to your priority. So let's begin with an example. Here we have an example. Here we have some processes, 4 processes, and we are going to assume the burst time, we are supposed to assume the arrival time as they have all arrived at time 0, and we have their required burst time. This is the execution time for which we need to execute these processes, and their respective priorities are also given right here. So let's find out the one with the highest priority. 1 is the highest priority, so this should be the first one to get executed. Then after that, after 1, which is the second highest priority, 2, so this should be the second one to get executed. Then 3, third one to get executed, and then 4, which will be the fourth one to get executed. So P2 is supposed to get executed first, P1 second, third is P4, and then fourth is P3. So let's begin with our CPU allocation part, that is building up our Gantt chart. We always begin on time 0. So the very first process, depending on the priority, we are supposed to give the CPU. So the very first process to get the CPU is supposed to be it's supposed to be P2 because its priority is 1. So let's give the process the CPU. So P2 will be in the CPU. It is supposed to allocate for 3 time locations. So here we go. Till time unit 3 it will get executed. After that the P2 is basically completed. The execution of P2 is completed, so it's out of the list. Now we'll go to a process with the second highest priority, and that is nothing but our P1, as we have discussed before. So it's time to give P1 the CPU. So let's give P1 our CPU. Let's give P1 our CPU. Now P1 has the CPU. It is supposed to execute till 21. So 3 plus 21 is nothing but 24. So it will execute for 21 time units. With this, the execution of P1 is complete. And then we go to the third highest priority, that is nothing but P4. So P4 gets the CPU. P4 is supposed to get the CPU. P4's running time, burst time is nothing but 2. So for 2 units, it will get the CPU. Time units, it will get the CPU. So 24 plus 2 is nothing but 26. With this, the execution of P4 is done. Next, we go to the last and final priority, that is 4. So priority 4 is for P3. So we'll give the CPU to P3. It is supposed to execute for 6 time units. So here we go for executing for 6 time units, and with that we reach 32. With this, the execution of P3 is also complete. So now our next task is basically to find out the turnaround time, which is nothing but completion time minus the arrival time. So here we go, P1, P2, P3 and P4. So let's see P1's completion time. P1's just completed over here to 24 minus 0, P2 over here, P3 at 32, P4 at 26. Just find out what it is. 24, 3, 32 and 26. Average turnaround time is nothing but 24 plus 3 plus 32 plus 26 divided by 4, which is nothing but 21.25 time units. The next step is basically to find out your waiting time, which is nothing but turnaround time minus burst time. So here we go, P1, P2, P3, P4. So let's write the turnaround times minus the burst times. So P1's burst time is 21, P2's is 3, 6 and 2. Let's find their values. It is 3, 0, 26 and 24. Let's find the average waiting time, which is nothing but 3 plus 0 plus 26 plus 24 divided by 4 is nothing but 13.25. So here we get the answer for the same. Thank you.